The Dr. Yellow. What if there was a bullet train that most people in Japan have never seen, even though it runs on the same tracks as their daily commute? The Dr. Yellow is exactly that. It is a specially built Shinkansen used for inspecting the high-speed rail network across Japan, painted bright yellow so it stands out from every other train on the system. It runs at full bullet train speeds, while its onboard equipment measures track wear, overhead line tension, and signal accuracy at 270 kilometers per hour. Its schedule is never officially published. It appears roughly once every 10 days somewhere in the country, and Japanese train enthusiasts consider spotting it a genuine stroke of luck. Parents tell children that seeing the yellow doctor brings good fortune. Only 2 Dr. Yellows exist in active service, both operated by JR Central. They are among the most photographed trains in Japan by people who have never actually ridden one, because you cannot buy a ticket. It is a bullet train that runs in the shadow of every other bullet train, and it exists specifically to keep the entire network alive. The Vomit Comet. Sometimes engineers solve a problem so aggressively that they create a new one. The British Advanced Passenger Train, or APT, was designed in the 1970s to go faster than any other train in the United Kingdom without needing new tracks. The idea was to build a train that could tilt as it went around corners, letting it take existing rail curves at higher speeds without derailing. On paper, it was brilliant. In practice, the tilting system worked exactly as designed, but it worked so aggressively that passengers on board began to feel violently ill. The tilt combined with forward motion produced a specific kind of motion sickness that no amount of engineering could fix. Journalists on the inaugural press run reported vomiting in the aisles. The tabloid press labeled it the Vomit Comet within days. British Rail quietly shelved the program in the early 1980s. Ironically, the tilt technology developed for the APT was later licensed to Fiat in Italy, refined, and became the foundation for the Pendolino trains now used across Europe. Britain invented the future of trains, and got sick doing it. The Reaper. Not every high-speed train that fails does so because of the train. Sometimes it fails because of the country around it. The German Transrapid was a magnetic levitation train developed over 4 decades, starting in the 1970s. It floated above its track using powerful electromagnets, eliminating friction and allowing speeds well above 400 kilometers per hour. A full-scale test track was built in Emsland in northern Germany, 31 kilometers long, and the Transrapid ran on it thousands of times without a single mechanical failure. Then in 2006, a maintenance vehicle was accidentally left on the test track, and the Transrapid collided with it at 170 kilometers per hour, killing 23 people. The program never recovered. Germany canceled all domestic plans for the technology. The Emsland test track was dismantled between 2011 and 2012. The only place the Transrapid still operates commercially is in Shanghai, where a version of the German technology carries passengers between the airport and the city. In Germany itself, the track is gone and the trains sit in museums. It is a story of a technology that worked perfectly for decades and lost the political will of the country that built it after a single accident. The Racer. Some trains break records over months of steady testing. This one broke the world speed record in 15 seconds, and then never did it again. On the 3rd of April 2007, a heavily modified French TGV was accelerated down a specially prepared section of high-speed rail between Paris and Strasbourg. The overhead power lines had been boosted to a higher voltage. The wheels had been enlarged to spin at unusually high speeds. The gearing had been altered. The train hit a peak speed of 574.8 kilometers per hour, breaking the world speed record for any conventional train on rails. The record still stands today, more than 18 years later. The modifications required to reach that speed made the train unusable for regular service. It exists now in preserved condition, having spent its life proving a single point that no other conventional train has ever matched. The Psychic. Some trains seem to defy the laws of physics themselves. This one floats above its track without ever touching it. The Shanghai Maglev is the fastest commercially operating train in the world, reaching 431 kilometers per hour on a 30-kilometer route between Pudong Airport and the outskirts of Shanghai. It uses German Transrapid technology, adapted and expanded by China, and floats using magnetic levitation with no friction and almost no vibration. The full journey takes less than 8 minutes. It has been running since 2004 and continues to operate today. What makes it strange is not the technology, but the geography. The train only serves this one short route. It has never been extended, never been connected to the wider Chinese rail network, and never spawned a second Maglev system anywhere in China. It exists as an isolated demonstration of what high-speed rail could be, running the same 30 kilometers over and over again at the fastest sustained passenger speed on Earth. The Widowmaker. Some trains earn a good reputation over decades of reliable service. This one earned a terrifying reputation in a matter of test runs. In 1988, an Italian train called the ETR 450 broke a European speed record and simultaneously came close to disaster. It was one of the first tilting high-speed trains built for commercial service, and during test runs at speeds above 250 kilometers per hour, the tilting mechanism began oscillating uncontrollably in a way the engineers had not predicted. Passengers on early runs described the sensation of the train violently jerking side to side while traveling at highway speeds. The design team eventually solved the problem with computer-controlled dampers, and the ETR 450 went on to serve Italian high-speed rail for decades without further incident. But the early runs became legendary among European rail engineers as an example of what happens when you push a mechanical system faster than the physics allows before the software catches up. It survived, its reputation did not. The Cruiser. Most high-speed trains are built to beat other trains. This one is being built to beat aeroplanes. The Chinese CR450 is currently the fastest commercially planned passenger train in the world. It is designed to operate at a sustained cruising speed of 400 kilometers per hour on regular commercial service, which is faster than the top speed of most fighter jets during takeoff. To achieve this, Chinese engineers had to redesign almost every component of a normal high-speed train. New brake systems capable of stopping the train from cruising speed without buckling the rails. New track geometry to prevent lateral swaying at the target speed. New aerodynamic profiles to reduce noise pollution to legal limits inside the cabin. The CR450 completed its first successful test runs in 2024 and is expected to enter full commercial service within the next few years. When it does, it will make every other high-speed train in the world look slow by comparison. The Sub-Zero. Some trains float above the tracks by a few millimeters. This one floats above them using magnets so cold they are almost at the temperature of empty space. The Japanese Chuo Shinkansen L0 is designed to travel between Tokyo and Nagoya at 500 kilometers per hour. It floats above its track using superconducting electromagnets cooled to nearly absolute zero. It does not touch the rails at all during high-speed operation. In test runs on the Yamanashi test track, it has hit 603 kilometers per hour, which is the highest speed ever recorded by any manned rail vehicle in history. The full commercial route is being built now, mostly underground, cutting through the mountains of central Japan in tunnels that will make up over 80% of the total route length. The project has been under construction since 2014 and has faced repeated delays, environmental disputes, and cost overruns that pushed the total budget above $90 billion. When it opens, it will link Tokyo and Nagoya in 40 minutes, cutting the current journey time in half. The Jetpack. The final entry on this list, technically, never became a high-speed train. But the fact that a working prototype hit 430 kilometers per hour in 1974 is what makes it the weirdest. The French Aérotrain was a jet-powered hovertrain designed by an engineer named Jean Bertin. It did not run on rails. It ran on a concrete beam elevated above the ground, hovering on a cushion of air produced by fans underneath, and propelled forward by a jet engine mounted on the back. During test runs on a dedicated track outside Orléans, the prototype reached speeds that no French train would touch again for over 30 years. The project was cancelled in 1977 because France chose to invest in the TGV instead, a conventional high-speed train that used existing rail infrastructure. The Aérotrain's test track was never dismantled. It still exists today, a long concrete elevated line stretching across French farmland, slowly cracking and being reclaimed by weeds and wildlife. Local photographers walk along it. Aviation enthusiasts occasionally repost images of it online. The world quietly forgot that in 1974, a French engineer built a jet-powered train that hovered above a concrete rail at over 400 kilometers per hour, and then decided it did not need one. If you want to see more strange machines from history, subscribe to Odd Machines and let us know in the comments which one of these you would actually want to ride.